Morning. Just playing with Goosey Poo here. She's playing on my iPad. She loves lying on top of it, right? Say hi, Goosey. Say hi. Say hi. Say hi to the internet. Hey, baby. Hey. Oh, now she's playing around with it. Hey, Goosey. Too cute for your own good. Oh my gosh. Goose. Okay. Good morning. Okay, Goose, you're gonna have to move soon because you are messing around with everything. Oh my gosh. Okay, Goose. That's enough. Okay, where do we go? Good morning. Okay, sweet. Alright, yeah. I love you, but you gotta go. You gotta go. Why don't you go over there for a bit? That's good. Yeah, that's good. Okay, so we're gonna get started any minute now. Good morning. Just wanna make sure my microphone is working. Yeah, yesterday I had some issues with my microphone. Looks like it's all good though. Okay, yeah. I love you too, Goose. Okay. Let's see here. So yesterday we did a bit of a review on systems of linear equations, which is good. Today we're gonna take it to like the next level, at least the next level for us. Okay, sweetheart. Okay, I don't want to kick you out because you're so fun to play with, but gotta do a little bit of work here. We're gonna take it to the next level, at least for us. So this is gonna be systems of equations, not just systems of linear equations. We're just doing systems of equations. Do I know when we'll be getting our report cards? If I recall correctly, it's a good question. If I recall correctly, I think you get your report cards tomorrow. Let me just check my email. Oh yikes. High school reports. Information and instructions for parents and guardians will be sent out next Friday, so that's tomorrow, to access reports on Monday the 27th. Okay. Yeah, so we're getting it on Monday, but you'll get an email tomorrow. Your parents or your guardians will get an email tomorrow. Sure, I've got cat hair all over my face. You'll get an email tomorrow with instructions on how to access it. When are we going to get our marks for the redo? Oh yeah, I already marked that. I'll post your marks shortly, but anyone who did the redo assignment did very well. So I wouldn't worry about it. Everyone who redid their assignment increased their grade substantially. So I wouldn't worry too much about that. If you did the redo assignment, you did great, and your grade has improved substantially. So yeah, I wouldn't worry if I were you if you did the redo assignment. Everyone who did it did a great job. Okay. What are we doing today? We're doing systems of equations, and it's not just systems of linear equations. We are going to do systems, so systems of equations. Okay, and this is a little bit different from yesterday because some of these, I'll just put in brackets here. So these may or may not be linear. Okay, so we could have linear. Will that show on the report card? Yes, I got it. I got that marking done before the report card. So yeah, I submitted your improved grade. That's why I wanted that assignment done on that date was so that I would have enough time to mark it and include that grade in your report card. So your report card should be improved if you did the redo assignment. Yeah, no problem. Okay. So systems of equations. So these may or may not be linear. So a non-linear equation. So a non-linear equation. That means a few different things. So first of all, we don't have a straight line. So no straight lines when we graph it. Lines when graphing. And we may now have exponents. We may have some exponents on variables, among other things. It's not like all linear equations just have exponents on variables. There are many different types of non-linear equations, but this is you know, the ones that we're going to look at, probably the main difference is that they're going to have exponents on the variables. So so just a few examples. So we could have parabolas, right? That could be one example of a non-linear equation is a parabola, or I should also say like a quadratic. Okay. So let's talk a little bit about what systems of equations mean, sort of like on the larger scale. So what are we doing? With non-linear equations and systems of non-linear equations? So what are we doing here? So what's the purpose of what we're going to do today? Well, today what we're going to look at is we're gonna sort of consider this case visually. So we're going to take a visual approach to this. Okay, so in this case, what we're going to be given is I'm going to give you, so if I give you two non-linear, or I shouldn't say non, because I may give you a linear equation. It's just that some of the equations that we have now may be non-linear. So I'm just going to say two equations. If I give you two equations, and I'll write in brackets here, linear or otherwise, okay, because they may or may not be linear. So if I give you two equations, we want to find where they intersect. Or if they don't intersect at all. Don't intersect at all. Okay, so let's look at the different possibilities here. So I need a new page here. So the different possibilities. So we have, again, we have three possibilities. Or actually, you know what? Actually, come to think of it, there's four possibilities. I just realized that now. So there's four possibilities. There are four possible outcomes. Okay. So the first outcome is that we have. Well, let's. I want to be consistent with the book that I'm following here. Yeah. Okay. So we'll go in increasing order. So we could have zero solutions. All right, actually zero solutions. Okay, and what that looks like is, well, we're two equations. Oh yeah, I forgot one more thing. So I'm really sorry here. I'm a little scattered. So there's four possible outcomes in a certain situation. So the two equations I'm going to give you two specific equations first. So in this scenario, so our first scenario, we have a quadratic and a linear equation. And I'll write equation, EQN. Okay. So that's our first scenario where we have a quadratic equation and a linear equation, okay? And in that scenario, there are 4 possible outcomes. The first outcome is where we have 0 solutions. So this might look something like this. So here's my quadratic. I get some kind of parabola, and the parabola keeps going up in that direction and up in that direction. And so this is my quadratic right here, quadratic. And maybe the linear equation looks something like this, right? So in this case, there is no intersection. I'll just write this is my linear equation. In this case, I have 0 intersection. So no intersections, therefore no solution. Okay, so that's the first possibility, right? And you can see that visually, and that's why we're starting off with this visual approach. That it's plain to see that we could have a quadratic and a linear equation that have no points in common. So if they don't have any points in common, then they don't have any solution. There's no solution to this, because if we did have a solution, we would have to be able to find a point that is on the parabola, and we would have to have that same point also be on the linear equation, which is not possible. So that's our first scenario, if there are 0 solutions. Next up, we have 2 solutions. So number 2, okay, the first scenario is 0 solutions. It's confusing because it's the first scenario where there's 0 solutions. The second one is the second scenario where there's 1 solution. Maybe I should have called this the 0 scenario. Whatever. Okay. Second possibility is that there is 1 solution. Okay? 1 solution. Okay? And so that looks something like this. And I'm going to have something like this. Okay? So here's my parabola. I'll start off with a parabola. Oop, that looks awful. How about this? Okay, that looks good. And if there's 1 solution, then what it's going to look like is that our linear, so this is our quadratic. This is the quadratic, as if I have to say that. I mean, you guys already know that that's what a quadratic equation looks like. Okay, anyway, so this looks something like this. So you may have, oh shoot, I messed it up. You may remember learning last year when you were in grade 9, there's a unit that we learn about called circle geometry. And in circle geometry, you learn about something called tangents, right? And I'll just quickly do a little quick aside. So here's an aside here. So on a circle, you could have a tangent to a circle, and that tangent looks something like this, okay? And then we would say that this is the point of tangency. Point of tangency, and this line would be our tangent line. Okay, so this is actually a really important topic, and it's often overlooked how important the idea of a tangent is. Tangents are incredibly important in mathematics, particularly in calculus. The whole idea of a derivative, which is almost all of the first half of a first-year calculus class. So you usually spend several months thinking about tangent lines. So tangent lines are incredibly important in calculus, and they're important here too, because this linear equation, so this linear equation here, if it is tangent to the quadratic, that means that it touches the quadratic in exactly 1 point. So I will write that we will have one intersection. So we intersect at 1 point, and in brackets I will write where it is tangent to the parabola. So that means it only touches the parabola at 1 point. So it kind of just grazes it. Like, you can kind of think of, like, you can imagine, going back to this circle example, if I had a line that went through like that, then you can sort of think of the line like in this area right here. I should use a different color. In this area right here, like it's going inside the circle, right? It's going inside the circle. Whereas in a tangent, even though it's touching it, it always stays outside of the circle, except for the one point where it shares that point. So, and that would be the point of tangency. But it never goes inside the circle. It stays either outside the circle or goes on the very edge of the circle, never goes inside. So that's one possibility. Let's see. Okay. Okay, so that's where we have one intersection, and if we have one intersection, that should be intersection. Therefore, one solution. One solution. Okay, so that's another possibility. You can probably see where this is going. The third possible outcome is two. What was I calling them? Intersections? Yeah, solutions. So two. The next one is if we had two solutions. Okay, and that looks something like this, and you can probably imagine what this one looks like. So here is our graph, and so here's my parabola. Boom, boom. This is the quadratic, and in this case, I'm gonna make the linear equation look something like this. Okay, and we're gonna have two intersection points right here. And let me just label this. This is my linear. Okay, and then these two intersection points right here, these are my points. I'll say 2 points of intersection. Come on, eraser. There we go. So 2 points of intersection. Therefore, two solutions. Okay, and I said earlier that there were 4 possibilities. I lied. There's 3. The reason I thought there was 3 is because for some reason I thought we were doing a quadratic with a quadratic. With 2 quadratics, you can have the 4th possibility, which is where they're the same quadratic, or they're maybe they look different. They're 2 different expressions, but they represent the same parabola when you graph them, in which case you would have an infinite number of solutions. But in this case, we have 3 possible outcomes. We have 0 solutions. That's where they don't intersect at all. We have 1 solution, and we have 2 solutions. So what we're going to do is when we're first starting this kind of investigation, the thing that I want you to do is, so our strategy here, or our procedure, so our procedure is going to look something like this. So our procedure is given 2 equations. So that would be a or I shouldn't say a parabola, I should say a quadratic, and linear. We graph them, and then we observe their intersection points. Okay, and that's all we're doing. We're not really going to be using algebra yet. I don't think that we're going to do that today at all, actually. I think I'm going to leave the algebra for tomorrow. But right now, what I want us to get us to have a good feeling of is how this actually works visually. So what does it actually mean? Okay, so let's start off with an example, and then I'm going to get you to do an example. So here is an example. Where is it? Okay, yeah, I'm going to do this one here. Excuse me. Did not sleep last night. Okay, why won't you zoom in? Come on. Oh, there we go. Okay, so here's my example. And like pretty much anything with graphing, it helps to have graphing paper. So what we're going to do is we're going to solve this is my example. We're going to solve the system. We're going to solve the system y equals x squared minus 5x plus 4, and x minus y equals 1. Okay? We're going to solve the system by graphing. Okay? And just to make things a little bit nicer, I'll kind of format this so it's a little easier to read. Okay? So we're going to solve this system by graphing. Okay? So you know, this one right over here, this guy right here, is not in vertex form. This is in standard form, right? This, what do we call this? I think we call this general form. Is that right? I'd have to. It's been a while since I've looked at the different forms of equations. But yeah, I think that's what we would call general form, or maybe that's standard. I better look it up. I'm sorry. Okay, and embarrassing thing is I did this not long ago with the grade 9s. Let's see, where are we? Standard form. So this is in standard form as well. So both of these are in standard form. Okay. The difference between standard form and general form is that general form would be equal to 0. Right, and then we would put the -1 over here, basically move. Anyway, that's neither here nor there. The point is that we're gonna have to sort of manipulate these equations a little bit in order to graph them, right? Unless you're like really good at graphing. I'm not. I have to have things either in like slope-intercept form for linear equations. I mean, I can deal with different forms, but I much prefer slope-intercept form. And same with quadratic equations. I pretty much need it to be in vertex form. I can't graph it in any other way. There's probably other methods, but I don't like them. So let's start off with the quadratic. Let's do the quadratic. Okay. So I am going to put it in vertex form. So essentially, I've got to complete the square. So I've got y equals x squared minus 5x plus 4. Okay, we've done this 100 times already, so I have to complete the square. That gives me y equals x squared minus 5x, and we're going to do half of -5, so -2.5. -2.5 squared, that's equal to, well, 25 times 25. What's that? You know what? I better use my calculator for this one. 25 squared, or I should say 2.5 squared equals 6.25. I think I knew that one. I should have. Okay, 6.25. Okay, good. So that means I'm going to add 6.25 and subtract 6.25, and then don't forget about the plus 4, and I'll kind of move this out of the way. Now this is equal to y equals x minus, what was it, 2.5? Yeah, 2.5 squared. And then this is going to be minus, what is that, 2.25? Yeah, okay, great. So our parabola has slope, stretch equal to 1. There's no coefficient in front of the parentheses. And we have a vertex. So the vertex is at the point 2.5 and negative 2.25. Great. Okay. So let's graph this. So I'm going to go over here, and I'm going to make my graph like really big because I've got these decimals here, and I'm anticipating that might be a little annoying to deal with. So my graph is going up because it has a stretch factor of 1. Just going to check, make sure no one's yelling at me on YouTube. No, you guys are good. Okay, so it's got a stretch factor of 1, so it's facing upwards like that. It's going like that, just like the regular standard parabola shape. And it has a vertex of, okay, so 2.5, negative 2.5, so it's going to be somewhere down in the bottom left quadrant. I think we call that the third quadrant. So I'm going to put my my x-axis right around here. That looks good. Okay, and so we want to have some level of precision here because we're graphing it using, or sorry, we're solving it using our graph. So I'm going to say that that this is -1. This is -2. So I'm going over by jumps of, oops, that's -3, of 2, just so I have a little more resolution to deal with. So this is 1, 2, 3, 4, and then this is 1, this is 2, this is 3, this is 4, and this is -1, -2, etc. So I'm going, oh, sorry, I don't know why I said the bottom left. It's definitely the bottom right quadrant, so that would be the fourth quadrant. So I'm going over 2.5 and down 2.25. So somewhere like right here. Okay, so this is the point. Okay, so this is the point 2.5, -2.25. So that's my vertex, and I'm going over 1 and up 1. So I go here. Oh no, 1 is all the way over. So that's 2 spaces and then 2 spaces. So I go over there, and then same with the other side. So I'm right there, and then I go over 2 and up 4. So 1, 2, and up 1, 2, 3, 4. Okay, and that would bring me over here. Okay, and if I really wanted to, it might actually be a good idea to find the x and y intercepts, but I'm gonna leave it for now. Okay, so this is my parabola. Looks good, and you know what? I'm gonna zoom in here, and I want this to look a little bit better because we're going for precision, right? So I want that nice smooth bottom. That kind of sounded a little bit wrong, but whatever. Okay, so got this nice sort of transition. Okay. Okay, great. So there's my parabola. So I'm hoping that that's not something new, right? We've been working with parabolas and quadratics for a while now. Now let's grab the linear equation. So x minus y equals 1. So x minus y equals 1. And I'll say this is the linear. Oops, linear. And we've got x minus y equals 1. Or in other words, y is equal to x plus 1. So my y-intercept is 1 and my slope is 1. So I'm going over 1, up 1, okay? And that's really all I need for the intersection here. And it looks like we have a nice looking intersection point like right over here, right at this point. Now, here's the thing about this method is that like it's pretty close, right? It's pretty close, but I don't actually know exactly what that point is because this is not a perfect graph. I've done a fairly good job of of making my graph look really nice, but at the end of the day, it's just a graph, right? So so yeah, it's not perfect, right? It's not absolutely perfect. So let's see here. Now I'm wondering, did I do something wrong here? I feel like I did something wrong. Okay, x minus y equals 1. Yeah, I did something wrong. If x minus y is equal to 1, then y is equal to x minus 1. So that's a little bit of a mistake. Not to worry. I've made much bigger mistakes. Don't you worry. That's one thing that you learn in life is just when you think you've made the biggest mistake of your life, you can definitely make a bigger mistake. Okay, so get rid of that. Okay, so what is that? X minus 1. So my y-intercept is -1. So I'm going down here, okay, and oh, look at that. I already know that my slope is 1, so I'm just kind of drawing it as is. Now I think So this looks like a good point right here. That looks like a good point. So what we're going to say, okay, so that intersection point is which point? Okay, well, that is 1, 0. 1, 0. Now, is that an intersection point? So the way we check is, so like our guess is that the point 1, 0 is an intersection point. Intersection. Okay? If it is, then we should be able to plug those values into both equations, right? And if 1, 0, like if x equals 1, y equals 0, if that works in both cases, we're good. So let's try it. So try x equals, what was it? X equals 1, y equals 0. Let's see if that works, okay? So in the quadratic, oh, did the light just change? Weird. I don't know. Maybe I'm just for some reason my iPad just got darker all of a sudden. Doesn't look like it changed on YouTube. Anyway, okay. So the quadratic. Let's take a look at the quadratic. So I've got x squared minus 5x plus 4. X squared minus 5x plus 4 equals y. That's what y is equal to. So let's try that. So if x is equal to 1, let's punch those in. So I've got 1, that's supposed to be a bracket, 1 squared minus 5 times 1 plus 4 equals 0. Is that true? Well, I've got 1 minus 5 plus 4 equals 0. Is that true? Well, 1 minus 5 is negative 4 plus 4 is 0. Yes, 0 equals 0. We're good. Okay, so it works for the quadratic. Does it work for the linear equation? The linear. Okay, well, the linear equation was x minus y equals 1. X minus y equals 1. So let's try that. If x equals 1, well, we'll have 1 minus, well, 0 is what y is. So 1 minus 0. Is 1 minus 0 equal to 1? 1 minus 0 equals 1. Yes, 1 equals 1. Absolutely. So this is a solution. So this is a verified solution. So we are verified. Just like on Instagram, those famous people get verified. Okay, so this is a verified solution. So that means that this is a solution. So really, the way this works is that we're graphing both. Oh, and would you look at that? Actually, it looks as though we should have two solutions. We have two solutions, but you can tell that this other solution is going to be pretty tough. That's going to be tough to find. Like, what the heck is this? Well, let's see if we can actually figure that out. Okay. So, can we even figure that out though? I don't think that we can in any reasonable way. Let's give it a shot. Okay. Let's see if we can find the other solution here. Okay. We're just going to have to be really careful with our parabola. So remember, our stretch is 1. We just have a regular parabola. So I've gone over 1, up 1, then I've gone over 2 and up 4. Let's go over 3 now. So 1, 2, 3, and I'll go up 9 from here. So here is 1, 2, 3, 4, 5, 6, 7, 8, come on, and 9. Oh, yikes. Okay, so I'm all the way over there. Okay, so I'm gonna make my thing go really tall like this. Oh boy, this is gonna be a doozy, isn't it? Okay, boom, bang. So you can probably tell this isn't my favorite method of solving systems by graphing, right? It's not actually that much fun. I don't think that this is a very good method. We are going to be using algebra. Oh, and look at that. There's a nice little intersection point there. Let's see if we can figure out what that point is. Okay. Okay. Why do I have this suspicion? Okay, yeah, you know what? Maybe that is it. Okay. Okay, so what is this point? This is the point, well, this is the point 5, 4, right? This is the point 5, 4. So let's see if 5, 4 works as well. Okay, so let's try x equals 5, and y equals 4. Okay, so let's try that one. I'm going to sort of get this verified business out of the way. Yeah, we know it's verified. So let's try this one. So I've already got the equation written down. So if x is equal to 5, then we got 5 squared minus 5 times 1 plus 4 equals 0. Oh, sorry, and that's supposed to be 4 rather. Plus 4. Okay, so 5 squared minus 5. Oops, 5 times 5 rather. Pardon me. I'm just copying the old one. 5 times 5 is equal to 4. So let's try that. So we've got 25 minus 25 plus 4 equals 4. Hey, look at that. It works. So 4 equals 4. Absolutely, that works. So maybe this did work. Okay, so the next one would be x minus y. So I've got 5 minus 4 equals 1. Yes, 5 minus 4 is equal to 1 because 1 is equal to 1. Hallelujah. Fantastic. So that's our other solution. So we have two solutions. Okay. The first solution is, what was it? 1, 0. 1, 0. And the next solution was 5, 4. 5, 4. So there you have it. So let's head over to Desmos and just take a look at a better looking graph than mine. Okay. So I'm gonna just grab this keyboard, put it into the iPad, and start punching away. Okay, so the first one, can I get rid of this ugly keyboard? I don't think I can. That's fine. Oh yeah, there we go. Oh no. Whatever. Okay, so the first one was what? X squared minus 5x plus 4. Okay, and we had y equals that. The next one was, what was it? X minus y equals 1, right? Come on. Let's do, yeah, I'm gonna say it's y equals x minus 1, because that's what it actually was. Okay, and let's just verify that this works here. Okay, so there's the solution 1, 0, and there's the other one 5, 4. Okay, great. I feel good about that. That looks like it worked out pretty nice. So that's basically how the graphing portion works. So it looks like we're pretty much, you know, running out of time here. So I'm gonna set up an exit slip for you now. I would have liked to have sort of one more example that you do, but it's hard to do like a little bit of theory and then an example, and then all fit that in 45 minutes. So I'm gonna just leave you with this system. So we are going to solve this system. Y equals x squared minus 4, and 2x minus y equals 5 by graphing. Okay? So you may have 0 solutions. You might have 1 solution. You might have 2 solutions. So let me know what your solution is. I also wanted to just show you one more quick trick with Desmos. So I might actually go a little bit over time, but I think this is kind of a good trick to have. So you'll have to bear with me for 2 seconds. I am going to go over time by just a little bit. So let me just first set stuff up in Desmos, and then I'm going to pull up the class website. Okay, yada yada yada. Okay, great. That's not what I wanted. mathbennett.com. Great. Okay, bring up the exit slip and then Desmos. Okay, now I will get this to show up, and I'll bring it over here. Aha, wow, look at that. You can see my whole screen now. So I'm going to just move this up a little bit. That looks good. Okay, I think this is going to work. So how much of my screen? I think you can see pretty much the whole thing now. Everything that I want you to anyways. Okay, so there we go. Okay, so I'm in Desmos. I want to show you something that I thought could really help. So when I've been looking at your exit slip solutions, and then same with some of the solutions on some of the assignments when I get you to punch in their Google form. And like let's say I want to write something like the square root of 2. Like how do you punch that into an exit slip that just has like a keyboard thing? Like there's no square root symbol on your keyboard. Well, there happens to be a computer language called LaTeX, and I'll probably talk about this a couple more times. I've been talking about it a little bit with my grade 9s, and they seem to be interested, and I'm wondering if you'd be interested in it too. So one thing that's cool about Desmos is that Desmos has a lot of stuff sort of going on behind the scenes, and part of it is making these symbols look so beautiful, right? Like that looks like it's straight out of a textbook, right? So here's a cool thing, and I just figured this out, that if you copy this, so if you I guess I can't right click it, but you'll just have to trust me. I'm hitting Control C, which is on Windows. That's your that means copy. So if I copy this, then and I paste it into here, it gives me what's called a LaTeX. That's like the LaTeX symbol for the square root of 2. So if you ever have some kind of like big expression and you're not quite sure how to put it into like a submission line for our Google Forms, see if you can make it look nice in Desmos, and then just copy it and then paste it into the exit slip like that. So like let's say if we had like this big gnarly equation. Let's see if I can do some kind of like, okay, we've got the absolute value of this, and then it's all over 2x squared. Oh, and look how crazy this graph looks. So let's say I've got this, and how on earth are you supposed to put that into a single line? We'll just copy it and then paste it, and that looks crazy. But you know what? I've been using LaTeX for about a decade now, and I can read that very, very clearly. That makes perfect sense to me. So if you're not sure how to punch something in, go to Desmos, see if you can get it to look nice in Desmos, copy it and paste it right into here, and I will know exactly what this means. And if it does, if I don't know what that means, what I could do is I could copy it back out of here. I can put it into my little text editor here. I could paste it. Actually, I need a. Here, I'm giving you all my little secrets. Okay, so I can do this. So if I really didn't know what it was, what I can do is I could bring in my own LaTeX document. I could copy this and then paste it, and then compile it. I mean, I don't know why I'm showing you this, but what I could do is, let's just put it on my desktop, and I'll just call it ASDF, and I could compile it here. Oh, I should have saved it as asdf.tech. I don't know why I'm showing you all these details, but maybe you find it interesting that this is actually how mathematicians and like math teachers and stuff, this is how we make, oh, come on, you're really not helpful. Oh yeah, I gotta put dollar signs around it. There we go. This is, come on. Come on, there you go. You got this. Okay, so this is, and there it is. So if I really wanted to, I could punch it in and see what you were trying to say. So in this, I think that this actually opens up a lot of opportunities, because now I can start to ask slightly more complicated questions, not just like yes/no questions and things like that. You can actually punch in a full solution here. So I'll talk a little more about it maybe next week. I don't have any big plans to sort of require this anytime soon. I am going to put an assignment on the website hopefully by tomorrow, an assignment on radicals. But yeah, I just thought I'd show you that cool trick that you can use Desmos to generate LaTeX code, because LaTeX code is fantastic for I mean, it's not only fantastic, it's like it's the way. It's like the de facto markup language for writing mathematics. So I'm gonna hide my screen now and give you back that question. And let's see, is anyone yelling at me on YouTube? Oh, I closed the YouTube window. Hopefully that didn't break anything. You guys still here? Oh, there we are. Oh yeah, we still got 12 people here. Okay, yeah, you guys are all still here. So, okay, so yeah, that's that then. So that we solved, I want you to solve this. So give me either 1, 2, or 0 solutions. You don't have to worry about the whole Desmos thing, copying and pasting LaTeX code. Like you'll just have like, you know, a like maybe it's like 2, 7 or something like that. Punch those values in. Okay. Great. So so that's that. I'm gonna sign out. I'll talk to you guys tomorrow. And if you have any questions about this, as always, don't hesitate to ask. And yeah, have a good rest of your day. Bye bye.